Hey guys, how's everything going? This is JSer, who is not good at algorithms. I'm making these videos to prepare my job interview in June, which is actually 1 month later from Facebook. Yeah, let's start. Today is about 269 Alien Dictionary. There's a new alien language which uses the Latin alphabet. However, the order among the letters are unknown to me. Yeah, we receive a list of non-empty words from the dictionary, where words are sorted lexicographically by the rules of this new language. Derive the order of the letters in this language. So like WRT, WRF, because it's ordered this way, so T must be before F. Similarly, W is before E, R before T, E before R. So we get WERTF. This is order. ZX, so the ZX. ZXX, it's invalid, right? So return empty. We may assume all letters are lowercase. If the order is invalid, return empty string, like this. There may be multiple valid letters. Return any of the form. Them is fine. Okay, so let's first analyze what we can get from this input, right? The order between these two adjacent nodes means literally we could gather a relation between two letters. From each comparison, we can get T before F and W before E. So let's write that down. So the first compare WETF, something like this, right? And WE RT and ER. So actually, we're gonna generate a string from this relationship. Of course, there might be some other alphabets. Well, they don't matter. It doesn't matter because there's no restraint on them. We can put it anywhere. So how we could collect the result? Let's suppose that let's analyze what are the alphabets which could be put before them. Well, let's say there's T before F, so F could not be put in front. E could not be put in front. T could not be put in front. R could not be front. So actually, there's only W could be put front, right? So if we want to pick the letters in the front, which means there must be no this kind of pairs which points W, right? Is this right? Yeah. So we could actually loop through all the characters and check if there is some path like this pair with this character at the end, which means the path points to this letter. If no, we could collect it as into our final array, right? But after we collect the result, collect this letter, we need to remove the path from this letter, right? Yeah. And after that, we could do it over and over again and collect the result. What if there is the circle like this? Well, if there is a circle, there means we could not, which means when we match these when we meet the case like this, there will be no how to say, there will be no, how can I should put it? There will be no elements which has no path pointing at them, right? For Z, there was a path from X. For X, there's a path pointing to X. So that would be invalid case. So when we are trying to collect the result, if we find this case, there will be nothing there, but there is still there when there's still when there is still the pairs. Well, no, when there is still the characters, but we couldn't find any available alphabets, then it fails, right? So we can return the empty. Well, the things become clear. So how could we determine if there is a okay, the idea is kind of mature to us. Let's write it down. We first loop through all the letters, check if any path leading to it. How could we do this? First, how we could collect all the letters? Well, we loop. First, we loop through all the words, collect alphabets. Now loop through all the letters, check if it's leading to it. How can we do this? We could loop all the paths, right? No, sorry. We should collect the alphabets, and also we need to collect all the paths leading to it. So how can we do this? We could loop through the paths, and to see if there is it. So that would cost us a lot of time, because for each letters we need to traverse all the paths. It's a waste of time. There's finite paths, so we could actually store the paths as maps, right? And a reverse maps also. We could store a map of T to F, and also we should store a map of F to T. So we could check by check reverse map, all right? If yeah, check any math leading to it. If no paths collected as result. If no character collected and there is still letters, invalid, right? So when we collect the results, we need to remove the path, right? Remove the path. So after we collect it, we need to remove the result, remove the path from map and the reverse map, right? So now we can start working on it. First, we create a map. As called forward map and the reverse map, backward map. Okay, backward map. Now we need to loop through all the words. we need to compare the previous one. So let's say we start with use for index loop. We will traverse through the words by collecting the for collecting the alphabets. Of course, we need to say alphabets. We use a set to do that. Well, alphabets, we just add words I, J, right? Okay. Now, if there is previous word, get the map, get the path. How we should do it? It means when we are traverse through this, if there is previous one, okay, we could there and there if there's previous one and different than it, we should stop. So I'll use a new for map for this to make things clear. If I is bigger than 0, then there means there's a previous word, right? Compare with previous word to get the path. For j equals 0, j is smaller than words I minus 1 dot length, j is smaller than words I dot length, j plus plus, right? We compare it. So if words I minus 1 is not equal to words I, j, if they are different, we're sure we can break, right? And there's a path called with the letters from previous one to the second one, which means I'll add it to forward map. Set words I minus 1 j 2. Oh, there might be one letter to several different letters, so it will be the map would be from set to. It's like this, right? Yeah, if I cast the variables const from equals words I minus 1 j. I'll do it like this. I j I j, and if from is not to 2, if from is different from 2, then we will add it to the path, right? So if it is not initialized yet, we set from as new set, and now we could get from add 2, and we break, right? At the same time, we need to add it to the backward map, right? We do the same. If backward map has 2. Background set 2 new set. Get to add from. Okay, so after these 4, if we for check. Okay, so with the previous one we get the path, break, and if we wait, if the J, if one of the 2 words is traversed, there might be some letters still left, right? In one of the letters, might be. There's a case that if the previous one has longer digits letters than the latter one, then it is invalid, right? It should not happen if they are all matched. So we say if we break, and if we break, it's okay. But if we get it to, if how can I do this? The only case that it is invalid is that J will be the latter one is traversed, and the previous one is still there, right? So invalid case if J equals words I dot length, which means that the latter one is already all looped, and J is not equal to words previous ones next. Then we should break and return false. There's false, so we could return empty. Okay, so now when this is done, we will get now alphabets, forward map, backward map are all generated. Now let's do the second one. Loop through all letters. Check if any path leading to it by checking the reverse map. And now we collect the result. Right? So we create a result array. We traverse through all the alphabet. I just use T for short. From alphabets. Wow, I use a character, okay. It off, not from. If there is no path pointed to it, collect. Cool. So if backward map has character, if there's nothing there, I can say result push character, right? And we need to remove it from alphabet. For set is delete. We'll do this round by round. So actually, we need to before this we need to use a while loop, right? So when there is still alphabets in this set, then we loop through the alphabets. As we mentioned, if no letters collected and there's still alphabets there, we should return it's invalid case, right? So I'll set a flag. Found is head found. We set it to false. We found this, we updated it. And when all the letters are traversed and still there is nothing found, if nothing found, because we're in this while loop, alphabet is not empty. While for this while loop, we delete it. So if not found, and there is still letters, we return empty, right? This is invalid case. It means there's a loop in it. Now after we collect it, we need to update the map. Update both maps. It is here. We collect it and we need to remove the pass. Yeah, we need to update both paths. We do it here. Wow, the removal part process is simple. Remove it from. We check the forward map, and first we delete the elements in the forward map, and delete the backward map from them, and then delete the forward map. Right? It's like we want to delete T. We first find the 2, right? From the F, and then delete the F from the reverse map first, right? Yeah, cool. So because there is not okay, my if not we first go to the forward map, but it might be empty, right? So if forward map has this character, if it has it, so set twos equals forward map get character. Delete character from a reverse map of each 2, right? Froms. Okay, we will for let 2 of 2s. If there is a 2 in a forward, there must be a path in the reverse in the backward, right? So we will get froms equals backward map and get 2, and we will remove it, delete character, right? And if it is empty, remove it. Backward map delete 2, right? And now if the from map is empty for this character, we could remove it. So if 2's.length is empty, we forward map delete it. Delete the character. Okay, so now we updated the 2 maps. Yeah, and no student is invalid. Okay, so actually we have done. We're finished. We return the result joined by empty. Let's try to review our code one last time. For a case like this, we first traverse through all the word, and but first we collect all the alphabets. Is your set, so it's okay. This for loop is right. This is right. And if it's a second word, there will be a previous word, so we can do the comparison. So we start with the index for both letters, and at each when any of them is traversed, and we get the front and get the two. If they are different, we update the backward map and forward map. Forward and two. Cool. And we break. Yeah. And there's an invalid case if J is traversed down and the not previous one is not. Previous word is longer than this one, then it's invalid. Cool. Now we collect the result. When still there is alphabets there, we check if if there is nothing pointing to this character. So backward map, if is empty, we will collect it. After we collect it, we delete it from the alphabets, and we set is head found is true. When there is nothing found during in one of the check, and there's still alphabets, it means it's invalid. Okay. When we are collecting this character, we push to the result. We delete from the alphabets, and then we need to update the two maps. So if forward has this character, we get the twos of this forward map because if we have, right, if they pass from this point, we get the twos, and for each two, we need to delete from get. We delete from the character. If there is nothing from froms, we delete the two. Yeah, and if there is nothing in the twos, we delete it from the forward map. I think this should work, right? So theoretically, the algorithm works. Let's try run the code. Of course, J is not defined. Where is it? It's 51. J. Oh, this is Euro mistakes I made. A common mistake. I need to define here. Cool. Let's try to submit. Yeah, we are accepted and faster than 77%. Let's try analyze the time and space complexity. Time. First, we for all the words. I mean, I say this actually takes n. N means the total length of all the characters, right? Okay, this takes us n. For each, this extra for word, we compare all the words. Actually, each alphabet actually will be checked once for the previous one, once for the latter one only, right? So actually, it's another linear time. Cool. A map, it's constant, and then we will check alphabets. It's still linear time. For each, we will get one character from alphabets if the previous one has it, and direct access. Remove direct. Wow, isn't it this the? Wait a minute. So for each word, for each character, so isn't it linear time? N is the total characters. Let's check it again. This is linear time. Oh no, this is linear time, but this is not. for each word. This is for each word. We compare them with previous word, right? So if there is like let's suppose if m-nth by n word, this will be m, this is n, n word, m-nth, so this is n, this is m, and this would be m again. So this is a direct access, so it's m and n, and for this would be alphabets mn, and this is direct access. Update for let 2. For the worst case, there will be mn. Oh, there is something like this. Worst case is that here will be m and n, right? There will be a path for each of the pair. For this case, there will be worst o m n minus 1, and this will be m n. So actually, this costs much more time. If we say there is a totally n letters, it would be actually n squared, right? Because n minus 1 plus n minus 2 plus 2, 1. So it's n squared. Space, we keep a forward map and backward map. It's all linear to the count of the total length, right? Alphabets, total length. But in this format, there will be maximum n minus 1 nodes in the set. So actually, it's still, I think it's n to the square. So okay, that's all for this solution. Actually, could we improve? Actually, yes. There's this is not came by me. I saw some materials. The first solution actually I did make it, but the second improvement I didn't come up with it. So we are using a backward map to keep track of the previous one, right? Actually, when we are doing the here, if backward map has this character, actually we could only, you see, we are syncing the forward map with the backward map, right? Actually, we could only keep track of the length of the count of the paths which leads to each node. So the operations like this set and get could be compressed into -1 and -1 and +1 and -1, right? So the forward map is inevitable, but backward map, we could use count method. Cool. I'll try to rewrite it another without only you avoid keeping track of path heads. So for backward map, we will use what? We will use count inbound map count. I'll use this one. So it's character to count of paths leading to it. This is a number, is count. Okay. So when we are generating a backward map, we will use this inbound count map. It's not set anymore. It should be 0. So we should get set it to set it to set it to with +1, right? So get 2. Here's a problem, that what if the 2 is the from and 2 is the same? So this is not right. When we're getting a from is not from, we set a new set and we add to it. It's not okay. I think it should say if we get from has to, if there's no 2 yet, we add to it. We add to it and we update the inbound count, right? To avoid the duplicates. So now we add it only if the 2 is not added. After we add it, we update the inbound count +1. Cool. Now this is the same. This is the same. So here it becomes, for each character, we check the inbound count if it is 0 or if it is 0 or not. So it will be, if there is no inbound count, of course it's okay, or it has it but it's 0. For the 0 case, we would remove it from when we are up processing it, so we could avoid this, I think. So inbound count is, there's no path leading to this character. We push it, we delete it, and head is true. Now, if it has forward map, we will okay, we choose for each of the twos. Where did we remove it from the? Delete the forward map. There's a problem here. Wait a minute. For each character, if there's for the previous solution, if, and then for each did this two's length. Oh, there's a problem of previous solution. Where did we remove the from map? We didn't, but we remove it from the alphabet, so actually it was not traverse anymore. Okay, I think we should do that. Okay, anyway, if forward has this character, we get all the twos, and for each two, instead of delete the froms, we subtract one from each of the inbound, right? So it's inbound map get 2, set 2 inbound get 2 -1. Okay, now if inbound get 2 is 0, We delete these two. Cool. I did a mistake. It's actually we should. I made a mistake. There is nothing like this. This does not work. It should be just delete it. Sorry. Okay, so we did it from forward map. Delete the character. Doesn't matter, but deleting it would be better. Okay, set for. Oh, I think this should work. Hope there will be no mistakes. Cool. Let's submit. Yay! We've improved it with another. So there's a slight improvement, but the general idea is the same. So the time and space complexity for here, time, the core would be here, right? So character would be the length of our total alphabets, and still there will be twos, right? So it's worst case, it's the same for worst case, two. Space, well, forward map, it's linear time, but yeah, still there will be like for paths for all of the rest characters. So it's still like this, but it's generally better than the previous one. We've reduced a worst square, quadratic space into this linear space. So this is obviously is better. And also the time here, you see for the I made a mistake here. So this is the total length of the alphabets, and for each we use twos. For each two, we updated the character. No problem, no problem. I just thought maybe it's a cubic, but there's no loop from this so it's direct access. It's okay, and it doesn't change the time complexity. Anyway, that's all for this problem. Hope it helps. It's a little complicated, but the idea is really pretty straightforward. The only error prompt point is that we need to handle two invalid case like here and here, right? Okay, that's all. Hope you enjoyed it, and see you next time. Please don't forget to subscribe my channel. There will be more and more videos about algorithms and front-end development. Yeah, see you next time. Bye bye.